Hey, there he is.
Good morning, Renz.
Good to see you.
Good afternoon for you.
Good afternoon. Good afternoon. Good morning for you.
Yes.
Pleasure to meet again. And good topic today, I think.
Yes, absolutely.
So we still have to wait. We have 4 more minutes, and people are already here.
It's good.
Let me, for everybody already listening, let me share the link where you can get a certificate, because otherwise we typically have to answer lots of emails afterwards, like in the range of like 200 emails for a certificate. So we automated that last week, finally. And, I have Andre with me who did that for us. So that's very welcome. Let me double check if it works. Yeah. Okay. If you like a certificate, it's the link. So how are you feeling, Ankur? Everything fine?
Absolutely. Absolutely. I think like I have been swamped with many things over the past couple of weeks, but absolutely ready for this conversation. And I think like this is something that so much is happening in this space anyway. Definitely. So it's going to be interesting and exciting 1 hour. And I think the audience will engage with us in terms of like the questions. So
I hope so. So for your information, it's a webinar setup, which means that they cannot unmute, right? So they can only put something in the chat. And given that we have 1,150 signups, I'm not going to make you read the chat while you're speaking, because it's going to get really confusing very fast. So I'll do that for you, and I'll for all the questions that pop up, I'll make a note here in my Evernote, and I'll give them to you at the right time.
Okay, perfect.
So to make your life a little bit easier.
Thank you so much, Renz.
I know how it feels like to not have that assistant, and yeah, it's challenging. Okay, 2 more minutes. Let's wait. I see it's already. Yeah, I think it's going to be quite busy. So when we started, we started the first webinar, I think halfway December, or maybe beginning of January. I think there were like 20 signups, and now we are in the range between 700 and 1,500 or so. So now it's getting busy. It's still manageable, but it's definitely more challenging.
That sounds such a good growth. Like there is so much traction to these webinars. I'm really glad to hear that like people are really enjoying it.
It's useful, right? And yeah, in 1 hour, if you have the right people on the call, right, like yourself, you can learn a lot, and otherwise it would take a lot of time to get your head around it. Okay, last minute. Shall we see if your slides work? I see Pakistan, I see India, I think, Philippines. We have a couple of guys from the Netherlands as well, of course.
I can't share my screen, Renz. Just FYI.
So I'm making you the host. Then you can share, but then I'm no longer the host. So I'll switch off my camera.
I can,
and you're in full control.
Okay. Otherwise, I can send you the presentation if in case that is helpful. Okay.
No, because it's easier for you to have control over that. Okay. Now you should be okay.
Perfect. Now.
Okay. And once that works, then I think we can start.
Can you see?
Yes.
Perfect.
Amazing.
This.
So I think I was planning to do like a little introduction, but maybe Ankur, with the new title change as well, maybe it's better if you actually do it. So we capture the full story.
Okay, perfect. Thank you so much, Renz. So hello, everyone. Good morning, good afternoon, good evening, good night from wherever you all are joining. I think it's an amazing to see so many people joining over this call. And as Renz mentioned, like we will be talking about climate today, and it will be more about like how exactly we need to solve the problem of climate change through the use of technologies that are already available. To give a quick introduction, my name is Ankur Dhanuka. I am a Chief Technology Officer working for Clean Tech Acquisition Corporation based in New York. And I'm also a consultant working with the World Bank Group in their climate change division based in Washington, DC. although I'm physically based in Washington, DC, these two roles between New York and Washington, DC allow me to kind of work in this space of climate change. A quick background, I have 12 years of experience working in the climate change space. I am an electrical and a nuclear engineer and a licensed nuclear scientist. And recently, I also pursued my public policy program from Harvard. And today, we will be kind of like discussing this together. This is not, I do not want this to be a conversation where I speak, you hear. So please keep posting your questions. Renz will help me walk through those, but then we will make it more kind of a interactive and engaging session.
So maybe to jump in very briefly, right? So for everybody, if you do have questions, please put them in the Q&A box to make Ankur's life easy. Then I will collect them and I will post them to Ankur, because you're not allowed to unmute yourself in this setup. It's a webinar, and Zoom will restrict that. But we can capture your questions and answer them, I think, maybe closer to the end. And if it's really pressing, urgent, then I'll throw it in earlier, Ankur.
Perfect. Just give me, I'm still trying to, I ended up clicking something. Now I'm not able to. Yes, now I can. Okay, perfect. Let me know, Renz, when we can start. And thank you again for having me here. I would want that you can quickly introduce yourself so that like it's more like that we together will be walking the audience through this particular tech.
Let's go. It's very hard. So maybe if you want to introduce yourself to the group here, then put it on the chat. Sometimes, of course, I see people making Discord groups and WhatsApp groups. Of course, that's all fine, right? But we're not going to set that up for you. But feel free to do that if you want to meet like-minded people. But let's not do that with 1,000 people together.
I just wanted you to introduce yourself. Like that's what I was mentioning. So maybe like quick introduction.
Quick. Okay, sure. So I think my camera is probably off, but most people hopefully have been in a webinar before. So I'm still the same guy. I'm Rens. I'm CEO of Kimo. Kimo is a learning company based in Amsterdam, but very soon it will also be based in India. So our focus is to teach the latest technologies like climate tech, but also AI in general, blockchain, metaverse, NFTs, to emerging markets. So that is technically what we're about. And every week we have two of those live sessions like we have today. And for those sessions, we invite experts. And I see a bit of weird stuff going on in the chat, but yeah, let's ignore that and continue.
Okay, so I'll move ahead and maybe like Renz, you can keep a check on what people are asking and let me know when I need to pause, Renz, if in case there is anything which we need to address then and there itself, or maybe like if you want me to kind of address those questions towards the end of it, we can do that. But then let me know. So
yeah, sure.
So welcome everyone. And today we will be, so I'll kind of like give a quick brief overview. We will be talking about climate technology, which is basically an intersection of like what are the scientific technologies available to solve for the problem of climate change. But then we'll also be touching upon the use of digital technology to kind of solve the problem of the climate change. Now, just a quick starter. So if in case, it will be really helpful to kind of understand that how familiar you are with climate change on a scale of 1 to 10, 10 being very familiar, 1 being not familiar. And it will be really helpful to kind of help us gauge where exactly our audience is and accordingly kind of like shape the conversation. So please go ahead and write your responses in the chat box.
And guys, it seems that we have two profiles in there that are trying to make things a bit more difficult, especially for Ankur to read the numbers. I'll see if I can remove them. I'm not sure how that works. It's the first time we're experiencing this, but I'll do my best to block this. Ankur, for you, the challenge to figure out the numbers in between all the spam that's coming through.
Absolutely no worries. So maybe like we'll go ahead and like let people evolve along with the discussion, Vince.
Can you maybe try, because you're the host, so I don't have the power, but it's we have George and we have your dad as the so if you go to attendees, then you can see both of them and maybe you can in some way get them out. I don't have that power anymore.
Yeah. So
I think there's quite some, actually, looking at the numbers coming through, there are quite some numbers that are relatively high. So awareness of climate change definitely is there. The numbers for the second question are lower, right? So the solutions that are on the table are...
Ren's quick question. So I removed George. What was the other name?
Something with your dad. So try with Y. Completely at the bottom.
I think
maybe
whoever the guy was, they themselves have removed themselves.
And the last one is John. John. Sorry for the rough start, Ankur. This is it's not easy to to start like this.
We need to manage these, filter out these. Okay, I think John also has removed himself.
He's also okay. Interesting way to spend your time, but let's continue.
Okay, just a moment. I found George.
And John is still there, actually.
Yes. Oh, George is there?
Oh, John is there.
Yes, John is there. Perfect. Now I remove George. Okay, perfect. Let me know if in case we need to filter out something else as well.
Great.
Okay. So as you informed, maybe like that's what exactly this session is about, guys, that we will be talking about what is the solution space available, both in terms of the climate technologies, scientific climate technologies, but then also with terms of like the digital technologies that we are using to solve for the problem of climate change. So moving ahead, maybe I'll start from a quick video as to what exactly dinosaurs have got to warn us about. So it's a good video put up by United Nations sometime early this year. So I'll quickly.
To make the screen bigger, Ankur, because we see both you and the screen.
Embedded, so
and we don't hear the sound.
You okay? You need a minute? Cool. Listen up, people. I know a thing or two about extinction. And let me tell you, and you'd kind of think this would be obvious, going extinct is a bad thing. And driving yourselves extinct in 70 million years, that's the most ridiculous thing I've ever heard. At least we had an asteroid. What's your excuse? You're headed for a climate disaster. And yet every year, governments spend hundreds of billions of public funds on fossil fuel subsidies. Imagine if we had spent hundreds of billions per year subsidizing giant meteors. That's what you're doing right now. Think of all the other things you could do with that money. Around the world, people are living in poverty. Don't you think helping them would make more sense than, I don't know, paying for the demise of your entire species? Let me be real for a second. You've got a huge opportunity right now. As you rebuild your economies and bounce back from this pandemic, this is humanity's big chance. So here's my wild idea. Don't choose extinction. Save your species before it's too late. It's time for you humans to stop making excuses and start making changes. Thank you.
Ankur, we have the same problem again, and we need to deal with it before we continue because everybody is having a hard time.
I removed Abdul Aziz.
And now we have Tizamra and Abdul Aziz.
So I have removed Abdul Aziz. What's the other name?
Tizamara. But I think the issue is maybe they signed up with multiple accounts and just get back in with a different name.
That's the problem. I think that will continue to be a problem then, because
can you incredible. This is can you disable the entire chat or make me the host and I'll try. And you can continue.
Can I give you the host permission?
Give me the host permission, and then you can continue, and I'll see if I can disable the entire chat.
Yep, exactly. So just let me give me a 1 second. Sorry, just give me a second, please.
So everybody that's listening, sorry for this this challenging start of the webinar. It's the first time we are experiencing this this kind of stuff. And the motivation for it is interesting to me, at least.
I think it's not allowing me to add.
Okay, if you go to participants and then panelists and then make me the host.
Yes, that's what I was looking for. Just a moment.
Okay, I can say actually, so I'm now the host. Great, I can reclaim the host, I see. So now the big question is if I can do anything about the, here, close chat. Yeah, the chat, oh, no, it's, it's not closed, incredible. Yeah. Okay. There is nothing. No, I don't think I can close the chat here. I cannot remove the whole thing.
So this is a little disturbing because the chats are really disturbing.
Yeah.
I don't know what's the solution to it, because they will keep popping up. Like, I have closed the chat window, but I don't think that's the solution. Like, let me know.
You'll still see it. So there's no way for me to close the chat here, which is also a bit of a weird thing. You would expect that they built that in, but it's not the case. If we restart the meeting, everybody has the same ID, so they can just restart everything. So that doesn't work either. Yeah. There's one more thing I can try, which is...
Can you go in the settings to, like, the meeting registration settings on the Zoom?
I'm there. Video. But it's accessibility. No, I can't. It's not there.
Okay.
Well, I can try, and I see that I'm going to see if I can go through the Zoom web portal. Give me a second. Also, that is, it's really difficult to do that here live in the.
Or maybe we just continue. I don't know, because this is disturbing. They will keep.
Yeah, they will keep doing that. Account settings. I'm going in right now. If we do solve it, then we can solve it for once and for all. But account settings, Zoom chat, users can share files and chat. No.
If you're not able to do it in the next 1 minute, maybe we can just let it be. We can request everyone to keep their chat boxes minimized so that they don't pay attention to it, and we can keep moving forward, friends. Because otherwise, I don't think it's more like giving attention to these guys who are trying to.
But I agree. I did change a couple of things.
Okay.
Which I'm not sure if you see any changes there. So I changed what I can change right now.
Because for me, it's like I just see the numbers increasing. I don't see the chat box actually. Like, I have just minimized it. Like,
okay, let's. So everybody listening, we still Yeah, I agree with Dankour. We just continue and close the chat. Maybe you see the numbers increasing, maybe you don't, depending on the things. But let's continue and we'll ignore this.
And sorry, everyone. It's the onus is on everyone, each one of us, to kind of keep the chat boxes minimized. I understand it's annoying and distractive, but let's try to kind of focus on what we are here to kind of have a engagement. Okay, so I'll move ahead, friends. I hope people just got a glimpse of the video, although we were distracted by the chat and other things, but we'll keep moving ahead. So just to kind of give you a sense of what we are going to discuss here. So it's a very preliminary question that we can start thinking about. That does anyone of us know what was the CO2 level in terms of parts per million, ppm level, that NASA measured in month of April 2022? Now, it's little relevant to what we are going to discuss and how exactly these two parameters, because in this question, there are two elements to it. One is CO2 level and one is parts per million. So we'll be talking in length, but if in case anyone knows it, please feel free to kind of like put it in the Q&A tab. I'll not recommend opening chat box to kind of not get distracted. So if in case you want to put your answers in the Q&A box, it's absolutely fine. Otherwise, we can keep going, because given our chat box is kind of spammed right now. So, okay. Maybe I'll just give 10 seconds more to it. People can input whatever they want to input, and we will also talk about it. Okay, so moving
wisely ignoring the chat. So let them think about it and we continue.
Oh, absolutely. I'm not even opening chat, Renz. Like, I just don't want to get distracted, so I'm not opening chat. So moving ahead, just to give you an answer to this, so it was 417 ppm, and we will kind of like relate it to what we are going to talk about, what exactly it means in the context of climate change. Now, the agenda for today's discussion will be mostly focused on understanding what is climate change when we talk about it. So we will be covering what exactly it is, how do we measure it, and that is where basically we'll be talking about ppm levels, and we'll be then describing the scope of the problem that we are dealing with here. And then we will be delving deeper into the climate technologies that are available with us, what are the digital technologies and the solutions that we have, and then we will try to find an intersection to the climate technologies and the digital technologies that are available there. So it will be kind of a good journey to walk through as to how we are kind of looking forward to a world where we are looking forward to digital technologies to solve for the problem of climate change. Now, as I said, I'll start very briefly from the climate change, the subject of climate change, what exactly it is. So typically, we have been defining climate by what we feel on day-to-day basis. So across the world, we have been living in different places. Renz is based in Amsterdam. I am right now in Washington, DC. Many people, you all are joining from different parts of the world. How we feel on day-to-day basis is something that describes that is what we mean from climate. How do we put it in scientific terms? So it's basically that what are the temperatures and the weather patterns emerging over a long term is something that describes the entire aspect of the climate. So you must be seeing that there are two elements to it, temperature and weather patterns. And holistically, that sums up that what exactly climate is. So this is more like the definition of climate, that like the intersection of the temperature and the weather patterns. And then if there is any shift happening, we term it as climate change. Now, whatever change is happening, it could have been natural. So you may ask that why exactly are we so concerned of it now, unlike 50 years ago or 100 years ago? So the shifts may be natural. It can be because of the solar cycles changes happening from the solar system. But then it may also be anthropogenic. Now, what exactly do we mean by anthropogenic when we talk about climate change? It's basically any human activities that we are conducting, which is resulting as a result of which the climate change is happening. So mankind, we use a lot of resources in our day-to-day lives, and using of any such resource kind of impacts the environment. It has environmental footprint, and that footprint results into climate change. How sustainably we are kind of using those resources define how much of the climate change is going to happen in that space. Now, moving forward, how do we measure it? Now, once we have a sense of what climate means, we have a sense of what do we mean by climate change, how do we measure it? Now, measurement is very important only for a reason, because unless and until you measure anything, you won't be able to find a solution to it. So finding a solution requires that we go for the measurement. And here for climate change, one of the biggest metrics that we have is greenhouse gas emissions. Now, just to give a sense, what exactly do we mean by greenhouse gas? So these are typically the gases that have the chemical and the physical property, which allows them to absorb and emit energy, which is coming to the surface Earth from sun and getting radiated back from the Earth's surface. Now, if there are a lot of greenhouse gases in the environment, it traps that energy and it makes it further warmer, further hot. Now, what are the typical greenhouse gases that does this kind of a phenomena, that results into these kind of phenomena? And if you see the third bullet here, it's very surprising that water vapor is something which also acts as a greenhouse gas. Now, we all have grown up realizing that water vapor is essential for the environment, because that's what exactly results into rain and humidity and kind of like makes it a favorable environment for us to stay on this planet Earth. That's something which we are looking for right now in planet Mars, as to whether we have water, water vapor, or any traces of it. So it's very interesting to see how exactly the same element might have a very detrimental effect if it's in huge quantity. And it's kind of a vicious trap that the more greenhouse gases, the more water vapor, the more water vapor, the more greenhouse gases. So it's cyclical in nature. But then let's just quickly catch up that what are the greenhouse gases that we typically talk about? It's typically carbon dioxide, which comes from burning of fossil fuels, primarily. Methane, that generally comes from agriculture activities, clearing of land and forest, any forest fire, landfills for garbage, which typically across the world, even in the United States, all the garbage is going into landfills. So all those landfills are resulting into methane emissions. Water vapor, nitrous oxide, ozone, chlorofluorocarbons. Now, although we, as a human mankind, we have achieved a significant stride in preventing the emissions of chlorofluorocarbons in the atmosphere, but we are still far behind in carbon dioxide and methane, especially to control for. Now, although these different gases have different metrics, to make it easier to understand and to have solutions around it, all the greenhouse gas emissions are then converted into their equivalent carbon dioxide value. What basically that means is that even if whatever methane emissions we see across the world, we convert it into an equivalent value of CO2 so that we have a consensus joint number for carbon dioxide emitted across the world. That just makes it easier for us to understand and have solutions designed around it. So we'll see that. And whatever I just mentioned until now, let's just see this audio visually, because it will just give us a different glimpse of what we are talking about in terms of climate change and the problem that we are dealing with.
If you can make the screen a bit bigger, because we see you and the.
So can you see? Can you? I can't, because it's embedded, Renz. Do you know how exactly I can do that?
Okay, let's continue. I think maybe it's on my side to just double click.
Right now, we're facing a man-made disaster of global scale. Our greatest threat in thousands of years, climate change. If we don't take action, the collapse of our civilizations and the extinction of much of the natural world is on the horizon. The world's people have spoken. Their message is clear. Time is running out.
The amount of carbon dioxide in the atmosphere now is 50% higher than it was in 1900. And not only are we piling in more and more carbon dioxide in the atmosphere, but we are chopping down the forests of the earth at a great rate. And the forests themselves are the most efficient consumers of carbon dioxide that there are on Earth. We're going to destroy the ground because the soil of a rainforest isn't very good. We are actually tampering with the climate of the earth and with the very atmosphere that we breathe. When we talk about the disappearance of the ozone layer, we don't know what will happen when the ozone layer goes. The world has become so fragile that we cannot subject the earth to the tortures we can now inflict upon it. When we talk about the greenhouse effect, we're talking about something that affects the entire earth. And these problems are life and death problems. They go to the root of the viability of the planet itself. If there's one thing that is biologically certain about the human species, is that it is a human species, one species.
If we don't stop the destruction of our natural world, nothing else will matter. Simply put, if we don't protect nature, we can't protect ourselves.
The only way we can solve a problem is by a human solution. Never can we sit back and wait for miracles to save us. Miracles don't happen. Sweat happens. Efforts happens. Thought happens.
Perfect. Thank you guys for patiently watching this video. So the quick takeaway from this is that definitely the human solutions, obviously the climate change that we are talking about is because of the human interventions, but then it's the human solutions that are going to kind of like help us like fight back the climate change issues that we are kind of dealing with here. So something that this video talked about, something that we touched upon early on in our presentation, that what exactly do we mean by the carbon dioxide emissions? As I mentioned, that all the greenhouse gases are kind of converted into an equivalent value for carbon dioxide. And that's what we kind of measure and find a solution to. So just to give you a context, if you see this graph, there is a steep increase happening from 1940, 1950. And even before that, if you see the increase started happening from 1900s, 1890, 1900. Now, what that signifies is that if you typically look into the history, the period of 1880 to 1920 is typically called the period of industrial revolution, where across the world, the industrial revolution started happening. We started building a lot of industries and we started having trying to kind of find solutions to various problems that we were having, like day-to-day comforts of our life. Now, that industrial revolution kind of started triggering the emissions. And we are right now at a stage where over the past 100 years, we have significantly made a stride in terms of the increase in the emissions to the environment. The current value is somewhere around 36 gigatons, it's billion metric tons or gigatons that we can say. So the metric, if you see on the y-axis, it's billion metric tons. And the typical value that we are right now facing with is around 36 to 40 billion metric tons. How to put that in context is something that we will talk about. But before we move ahead, this is something that gives you a snapshot just in the time frame of maybe 250 years. But it's very important to see it in the historical context. And that is where basically the next slide will build a very good context for us, that if we even go in the entire history, we can clearly see how exactly that translates into the ppm level in the environment and how exactly we breached that mark significantly after that 1920 period. Now, if you see, there has been a typical cyclical trend to the increase in the carbon level, CO2 level, and then decrease, and then again increase and decrease. But then off lately, right now, we are sitting at a ppm level, what we start in the beginning we talked about, at a value of 417 ppm. Now, if you typically see, we never breached the mark of 300 ppm. And these cyclical natures, just to give you a context, you all would have heard about ice age. That's exactly what it shows, that in the history, the earth has gone through those cyclical phases of ice age, and then the hot period, and then again this ice age and the hot period. Now, it's not something that has not been happening in the planet Earth. We have seen this cyclical trend of moving from hotter period to colder period to hotter period again. Now, these were all natural cycles that we were talking in the beginning because of the solar cyclical changes, but then never ever in the history, it was because of the human interventions. And that's basically is concerning for us, that this was not something that was designed in a natural way. It's artificial, it's because of the human man-made interventions. Now, just to kind of also give you a understanding sense as to where exactly these emissions are coming from. So it's not that we are only emitting. The earth has its own natural way of recovering these emissions. So the majority of the emissions are happening from the fossil fuel industry, as you can see the blue graph line on the top of it, as well as the other basic, if you see the majority of the emissions happening is from the atmospheric growth, the lighter gray line, and the land use change, kind of a greenish line at the bottom of it. Now, these three are typically the sources of emissions, wherein the two are human interventions, which is fossil fuel industry and land use change. Now, atmospheric growth is something that would anyway have resulted into carbon dioxide emissions. And how do we offset it? What exactly takes away those carbon emissions? Like, what helps it balance it out? So those are typically the last 2 points, which are ocean sink and land sink. So if you typically see the orange line and dark gray lines, these are the sinks. And what do we mean by sinks? Is that it helps absorb the carbon dioxide from the atmosphere. So typically we have emitting sources, and then we have absorption sources. And how do we balance it out is resulting into a net emissions of 36 to 40 billion metric tons every year. Now, where exactly are we? What do we mean by 417 ppm? The 417 ppm typically is resulting into a current average temperature increase of 1.12 degrees centigrade from what we used to have during the period of 1900s, early 1900s. Now, what does that mean? It means that the average mean temperature on the Earth's surface has increased by 1 degree. And that's what we want to control, because the United Nations, the World Bank, everyone right now, we are working on various scientific numbers, and we want to check it within 1.5 degree, because beyond 2 degree increase, it will be practically impossible to return back to the state of normalcy. We anyway, with just 1.12 degrees centigrade of mean temperature increase, as we saw in the video, we have started seeing the decrease in the ice cap. We have started seeing increase in the various erratic patterns of rainfalls. We have started seeing so many cyclones. So it's evident, science is telling us there is scientific correlation to the activities, natural events, natural hazards happening across the world, and the climate change. Now, this particular slide talks about that if we really need to keep a check on the 1.5 degree centigrade temperature rise. Now, that kind of becomes a goal for us, that we do not want the Earth's temperature to rise beyond 1.5 degrees centigrade. If we keep that check, what are the things that goes into that? Like, if we understand it pictorially, this particular graph helps us understand that what does that mean. We are already at a mark of 36 to 40 billion dollars. By 2030, it will require us to lower the emissions by at least 50%, meaning that our emissions need to be somewhere around 15 to 18 billion metric tons. And then by 2050, we really need to strive to get to the net zero kind of emissions, no further emissions to the environment. Now, these are the targets that we are working with. Just to give you a context, how we are running against time to really bring down those emissions when we have so comfortably built our lives around it. In the summers, each one of us kind of like feel very comfortable running either fan or air conditioning. And everything, whatever we are consuming, is resulting into some form of climate change. Every human activity is resulting into that. Now, just to give you a context, what the world is doing to fight against climate change, it's not something that we have started just now. These are the things that we have been working for long. So United Nations have set sustainable development goals. It has been set almost now 20 years ago, 19 to 20 years ago. There are 17 sustainable development goals that we have clearly laid out. And if you see the individual aspects of each sustainable development goals, even if it is not focused specifically on climate, it's mostly to give you a sense as to if we want to have a comfortable life around, what are the elements that we need to focus on, what are the policy measures that are needed, what are the technology solutions that are needed, and how do we put it together to make a comprehensive, sustainable life for people around the world. There are specific SDG goals numbers, which specifically focuses on climate change. Let's not focus on that. Let's try to understand how these are tied in together to kind of make the life overall sustainable. And that's what exactly this means. Now, before I move ahead, I'll just give you a very quick snapshot of what we mean when we want to talk about sustainable goals or sustainable development. Anything, so we all are living on planet Earth. What exactly do we mean by planet Earth and what do we mean by environment? So planet Earth is something that where we all are living. The environment is the ecosystem which we are kind of building our lives around. What are the key elements that goes into environment? I'll put it in three ways. It's the intersection of air, water, and land. We are living on land. We are using the air and water in some mixture, some format. And that kind of summarizes, if you look around, it summarizes what we are kind of consuming every day and calling it as our lives. All other things are material things that we are building around it. And that exactly precisely summarizes these 17 SDG goals, which tries to address those three environmental elements to make it more sustainable, make it more cyclical rather than just a one-time consumption kind of a solution. Now, the right side of this particular graph showcases that how do we need to approach these 17 SDG goals. So it kind of breaks it down into three major buckets. That what are the SDG goals that focuses on biosphere, what are the SDG goals that focuses on society, and what are the SDG goals that focuses on economy. Because these three kind of have an intersection and that kind of shapes up what are the emissions that we are experiencing in terms of the human activities that we are doing across the world. But when we talk about it, most of us in this call, we are joining from the developing and underdeveloped nations. And that's where the challenge right now lies for the entire world, that the developing nations and underdeveloped nations are continuing to struggle with conflicted priorities. Now, what do we mean by that? The countries such as United Nations, Europe, Japan, they have kind of achieved the economic growth through those early industrial phases of 1900s. And they are at a stage where their industrial revolution has already happened. But there are many geographies, many economies, such as India, Southeast Asian countries, African countries, where we are still kind of like in that phase of evolution, getting through that industrial revolution and making our economic growth. Now, any economic growth is bound to have environmental footprint. Not that United States didn't have it, not that Europe didn't have it, but now they are already at a stage where the pace of growth is not as significant what for developing nations are. So given these conflicted priorities, how do we account for the responsibilities for individual countries is something which becomes very challenging. This graph just shows you a context as to how China is really progressing in terms of the economy, but then their environmental footprints is also larger in terms of like the overall scheme of the emissions that we are talking about. United States is second, India is third, and then Russia, and it goes on. But then just to give you a context as to how the developed countries are kind of not progressing ahead in terms of emissions the way it is. Now, this graph just quickly captures, to give you a sense, because we will be building on this, that what are the sectors from where the emissions are majorly happening. Now, if we look at it, the emissions are majorly happening from the electricity sector, agriculture sector, and in a way, industrial sector. Now, typically we have a sense that transport is something wherein we kind of like build around it. But I think it's a mixture of so many sectors that results into those emissions. So primarily, if this is just to give you a context, that 25% of the emissions is coming from electricity and heat production, 24% of the emissions are coming from agriculture sector, 21% is coming from industry, 14% from transportation. So these are the significant, I'll say, 4 major buckets. Buildings is again another, but I'll not put it something as a major source of emissions for the developing nations, because developing nations still are struggling to find those resources in terms of building emissions. So other emissions are kind of like primary for the developing nations as well, emerging economies, as Renz put it in the beginning of our call. So this was kind of like to give you a background of what exactly do we mean by climate change, how do we define the scope of the problem, and what are the key tenets that we should know about climate change, emissions, sectors, and what has been the historical context of the emissions that we talk about. So I think I will put it in these 3 dimensions. And then we will move into what are the climate technologies that are already available with us. So here, I would want to summarize it in terms of like this particular slide where we talked that what are the sectors where we see emissions. Once we have a sense of the sectors, let's see corresponding to each sectors, what are the solutions that are already available to us that we as human mankind have been kind of like deploying and leveraging to the maximum extent. So in terms of electricity, when I mentioned that the electricity and the heat production results into 25% of the emissions, what are the climate technologies that are helping us minimize that reduction or reduce that emissions from that particular sector? So the first bucket of renewable energy gives us some insight of reducing the emissions from the electricity and the heat production sector. If you clearly see, each one of us now know how solar, wind, these are the kind of like the climate technologies that are helping us bridge that gap. But then simultaneously, the biomass and the hydel power also kind of gives you that kind of a sense of it. We are also in terms of agriculture talking about climate smart agriculture, which is helping us reduce the emissions. In industries, we are deploying various green measures such as renewable energy, that is in the first bucket, but then simultaneously also deploying other sustainable ways to achieve emissions reduction in the industrial sector. In the buildings sector, to reduce emissions, we are going for green buildings. What that means is that we are focusing on 3 different dimensions: energy consumption, how we can reduce the energy consumption in the buildings, how we can reduce the water footprint in the building, and how we can reduce the waste footprint in the building. So that kind of summarizes the things that we are focusing on green buildings. And then we are looking into green transportation sector. In transportation, every one of us know about Tesla as a company growing across the world, the electric vehicles market emerging across various geographies, and everyone kind of like looking forward to the electric vehicle market coming up. Similarly, we all are experiencing revolution in terms of the metro connectivity across different cities, different countries, and then we are looking for electric buses and public transport medium across the world. The last 2 icons kind of tell us that a city like London, they are aggressively pushing for cycling lanes and walking to kind of make it more like a sustainable transport medium. So those are the different changes that are climate technologies. I'll put it in bucket in terms of what are helping us achieve the emissions reduction. Now, for the sake of time, so that we have sufficient time for the Q&A, I'll move to digital technologies. That what are the different digital technologies that are already available? Now here, I'll not right now map it with climate, but then I'll just quickly walk you through the digital technologies that are available to the human mankind. And then we will talk how individual technologies will be helpful to solve for the problem of climate change. Now, I'll start with artificial intelligence, just to give the audience a quick sense of what exactly do we mean by artificial intelligence, although I think the Renz would have or maybe will be capturing artificial.
We've done some pre-work there in the past, but not in this context though.
Yes. So I'll relate it with this context in the further slides, but here I'll quickly just say that what exactly artificial intelligence means is it's nothing but a replica of human intelligence. The way we see, the way we comprehend data, the way we kind of learn, we do the complex analytical like problem solving in our head, and then have a language to present it. Now, that's exactly what is, if a machine is doing, that's called artificial intelligence. It's faster, it's better, And it also can be enhanced using computer vision, which basically is that having a capability to map it with the images. Machine learning is just a subset of kind of a subset of artificial intelligence, where it has the ability to learn automatically and improve with the learning in the learning process. Jumping quickly to Internet of Things, it's nothing but the hardware products having access to internet, and how exactly data communication can happen from those hardware products to a software platform, which gives us the capability to analyze that data and then again give a feedback to the hardware. And when I say hardware, it can be anything. It can be your mobile device, it can be your cooking utensil, it can be anything. Your light bulb in the home, it can be through Internet of Things. So just to give you a context, what Internet of Things exactly mean here. Distributed ledger technology, this is nothing but more like the notebooks that we used to have or we still have. So something like a notebook, but then more in an online format, where the data is whatever you are recording in your notebook is also going into a cloud server. So it's more like an online data register, and then that is something that you can control for, or then that is something that you can use for. So I'll put it that way in a more simplified version. We will definitely talk quickly about how exactly that is relevant to the problem of climate change. But then moving forward, just to give you a sense, so here we have, in the earlier slide, we captured the 4 different digital technologies that we know about. And here again, the other 4 digital technologies that we have right now with the human mankind. Big data is nothing but then typically a more complex neural network of data that is available. And how exactly do we have built the capability in terms of analyzing this data? The mixed reality, or like the cross reality, is nothing but the intersection of the virtual world and the real world. So say, for example, if I have to analyze a particular situation where I'm not physically available, this reality, cross reality tools, be it augmented reality, virtual reality, or mixed reality, helps me to kind of analyze that virtual situation. So say, for example, it can be somewhere in some different part of the world. It gives me the capability to kind of visualize that scenario and have an insight and an outlook with that particular scenario. So to kind of simply put it, what that means is it enhances your visual capability to analyze a situation where you are not physically present. Robotics, or including the unarmed vehicles, this basically means that how the digitally controlled, digital technology controlled products can help us make our lives easier by accessing in the areas where the human intervention might not be possible. Each one of us know the role of robotics in the space. We will see how robotics is really playing a significant role even to help solve the problem of climate change. Hyperautomation is nothing but an extension of the robotics. It basically gives the robots a capability to see things, visualize those things, and have an assessment as to how to perform to it. It's just a next level of the robotic processes, and it helps make it more automated. Now, given that we talked about these 8 digital technologies, let's put it in context of climate change, that how are these technologies relevant to the climate change problem? I'll divide the climate change problem into 4 different verticals. One is mitigation. So when we talk about climate change mitigation, what that means is that we really want to reduce or lower the emissions, or we want to prevent the emissions that are happening to the environment. The climate change adaptation, basically the second vertical, the vertical column, second vertical column. The climate change adaptation is nothing but a science which tells us that the climate change has happened, the effects are visible. How do you make the communities and the people across the world adapt to those changes? So say, for example, every summer you are experiencing even hotter summer. How do you adapt to it? One is we can prevent it. The prevention goes into mitigation. How do you adapt it? So that goes into adaptation. And then the third vertical column is disaster risk management, which basically means that if the disaster happens, so say, for example, if a cyclone hits a particular city, or if there is flooding in a particular city, how do we manage it? And then the fourth vertical column is environmental sustainability, which is the broader offshoot of what are the things that are not captured in mitigation or adaptation, and we still need to account for that. Now, The objective of this particular slide is to give you a sense as to how the 8 digital technologies that we talked about, how are they playing a significant role in helping us solve for these problems, and moving forward in future, how digital technologies are going to play a significant role in this transition of climate change. Now, just to give you a quick context of artificial intelligence in climate change mitigation, and these are the use cases. These are representative. These are not a comprehensive list. There are so many other uses for the same technology. This is just an example to kind of showcase that how are we using these technologies. So say, for example, artificial intelligence, it helps us to predict, say, for example, your energy demand, and accordingly, the supply side can be managed. Or alternatively, if artificial intelligence is integrated together with the satellite images, it helps us predict the plastic pollution, or it helps us identify where exactly the wildfires are happening, forest wildfires. You all must have heard about Amazon wildfires. You must have heard about Australian wildfires. How exactly those things can be taken care of if we have predictive analysis, artificial intelligence to predict those things, as well as have a catch on that. Similarly, for crop diseases, if we want to use artificial intelligence, it helps us do the better adaptation strategies. If we want to kind of like manage any post-hazard, like pre-hazard, natural hazard predictive analysis, artificial intelligence or machine learning can help us do that. Similarly, for sustainability, environmental sustainability, it can help us understand the precision agriculture technologies, that what resources, what crops, at what point of time in the day would require what kind of resources. So we can have those predictive analysis. In terms of Internet of Things and smart systems, how exactly those can help. So definitely, as I mentioned, these are nothing but the internet integrated together with the hardware. So if we have more data coming in from the on-ground field realities, we can be better equipped to kind of make informed decisions. So here, say for example, in climate change mitigation vertical, you can see that we are talking about optimization of vehicle traffic. Traffic is something which is a common problem across the developing countries, India, Pakistan, Bangladesh, everywhere we see these vehicle traffic issues. How exactly IoT is really helping us solve the problem of vehicle traffic. One of the very good cases is coming from Vietnam, where Vietnam has implemented severe, like very high level IoT integration with their traffic management system, and how we are kind of managing it through. Similarly, for adaptation, we have a lot of sensors to monitor soil conditions and guide us through the irrigation systems. Similarly, I think we are running out of time to walk through each one of us of this. So maybe Renz, you can quickly take a sense rain check of the time.
So we have 6 minutes officially. I would suggest, given the rough start, we continue for maybe 5 more minutes overtime. But the amount of questions I have for you, not based on my own thinking, but based on the smart audience we have, is quite significant. Okay. So I think the first conclusion is we have to do another session in the near future. But let's keep the last 5 minutes for questions.
Okay, perfect. So maybe let's do it this way. Let's try to wrap it up in the next 5-6 minutes and have 5 to 10 minutes running over in terms of like Q&A that we can quickly address. Okay. Yeah. And I think you will be hosting these slides on your website so that people can have access to it.
Actually, with your permission, I would love to send them over to everybody in the mailing list right away after this call.
Works for me, Renz. And then we can kind of like schedule some other session to kind of walk it through wherever people might have. Okay, so moving forward. Just to quickly give you a sense, so I'll kind of like start bucketing all the issues and will quickly give you a sense of how we are using these digital technologies in the different climate change solutions. So for big data and predictive analysis, say for example, we are doing a lot of optimization processes, both in energy, agriculture, as well as in transport. So here, the idea is to kind of understand that how we can have predictive analysis and optimize the resources that are flowing from the supply side to the demand side. Now, how exactly distributed ledger technology or blockchain is helping us. So we all are aware of the blockchain, but Bitcoin has been very famous. So although the distributed ledger technology that we use in the climate space is a bit different from the Bitcoin, because wherein like there is a lot of energy consumption because a lot of people are mining it, here no mining is happening. It's more like a ledger technology. wherein we are kind of like getting the data and then we are kind of doing the computation only specific to that particular asset. So here it's a different thing altogether. But then to give you a use case, we are using it for carbon markets, which is a very emerging market. We are using it for, say, for example, transparencies. We are using it for managing supply chains across the world. COVID has kind of like made it so prominent in terms of the supply chain issues that we have faced across the world. So it's something that we need to kind of like understand that how exactly distributed ledger technology and blockchain in the future can help us resolve the issues of the supply chain, wherein we don't have an insight and transparency currently across the world. In terms of cross reality, like augmented reality, virtual reality, mixed reality, we have been using it extensively for planning purposes. And when I summarize it, why I do so is, we are using it for the planning of cities. We are using it for the planning of building construction. We are using it for the planning of transportation, roadway construction, or metro line construction. So it gives us the capability to design things which we might not have sitting here or somewhere in the world and not being able to visualize things somewhere else in the world. Robotics and UAVs are something which are kind of very emerging market, especially with regards to the climate change, wherein we are seeing a lot of use of robots. So I'll quickly walk you through a quick video wherein like it will give you a sense as to how we are using robots in the different applications. Now, I'll not go through these videos right now, maybe just to give you a sense of what exactly do we mean by digital twins. So I'll run this video, but before that, what we do is we create a replica of whatever we want to do. So here we have created a replica of Earth altogether. And then across that replica, you can play around as to how exactly digital twins help. Since this session is focused on technology, I quickly run this video to help you understand that how this digital twin thing is happening.
The European Commission is creating a digital twin of the Earth. Destination Earth, or Destin-E, will enhance climate monitoring using Earth observation data. The virtual replica aims to represent virtually all processes of the Earth's surface, including human influences on food, water, and energy flows, as well as geophysical and meteorological systems. Set to start in mid-2021, the project will run for 10 years. Scientists hope these digital models will help understand climate impacts now and in the future. The digital twin is designed to test different scenarios, like showing whether a dike can prevent flooding in the Netherlands. Destin-E's outputs could inform policy decisions on climate-related risks. Artificial intelligence AI technology, such as neural networks, will speed up simulations, helping researchers pinpoint key insights faster. Launching in November 2021, Destin-E is co-developed by the European Space Agency and the European Agency for the Exploitation of Meteorological Data.
Okay, I'll pause it here because it kind of gives the quick sense of what exactly I wanted each one of you to kind of get a sense of. But yes, we can kind of delve into deeper once Ren send this material, this deck to all of you through mailing list.
So really, we're on the brink.
I need to move ahead, sorry, yes. So these next 3 slides will quickly walk you through, like I'll not walk through this because of the time like constraint that we have right now, but this is just to give you a sense that there is a lot happening in this space with the use of digital technologies to solve the problem of climate change. Just to give you a context, just in 2022, more than 526 startups have come up with digital technology solving the problem of climate change. One. Second, just to give you a context of how much capital is flowing in this space, more than $800 billion has been committed through digital technologies in various startups at various stages of the companies. This, when I say startups, even the big companies like NVIDIA or say, for example, Microsoft, they are doing amazing technology integration with the solutions for the climate change. So it's not that the capital together, like the financial capital will only help solve the problem of climate change. It's just to give you a context that the incentives are rightly aligned, that people are really trying to kind of solve the problem of climate change through the use of digital technologies. Here, I have just listed the few names of few companies working corresponding to each technology, digital technology, the companies that are working towards solving for the problem of climate change in agriculture, in different like supply chain issues, in energy sector. So it will be good for you to kind of like, I wanted you to kind of walk you through these things, but I'll just right now quickly walk through this and not get into the details of it. But these 3 slides will help you understand that the companies are really serious and are trying to kind of find solutions at the intersection of digital technology and climate space. Out of the 4 videos, maybe I'll quickly run 1 video because I'm already 2 minutes over what I committed to Renz. But this video will give you a sense as to how robots are helping us solve for the problem of climate change. And just to give you a context, this is one of the deals, one of the companies that we recently acquired a couple of months ago. So this is something which is very close to my heart. I kind of worked with these NASA scientists very closely in terms of understanding what they are building. So it's very amazing to see what they are building for the problem of the climate change.
From time immemorial, humanity has been fascinated with space. But perhaps we've spent so much time looking up that we've forgotten to look down. There beneath our noses,
oops, sorry,
lies the greatest hidden secrets and the key to our survival on this earth. Our oceans are truly the last frontier on this planet. But that is changing. Over the past century, the best thinkers, dreamers, and makers have made gigantic strides to achieve the impossible in space. But what if those same people redirected their attention from the galaxies beyond to the depths below? What could we accomplish? What could we create? What could we do to save our planet? What if we could transform what is possible underneath the ocean waters? And what if instead of requiring this, we had this? With premier technology from some of NASA's greatest minds, determined to bring green solutions to an antiquated blue economy, we have created the Aquanaut, the first and only underwater autonomous robot, the deep sea pioneer, a transformer, a shapeshifter, and a catalyst that is modernizing the way we communicate, build, travel, and work in the blue. And we are only just getting started.
Perfect. I'll pause it there and I'll move ahead. Sorry, every video is trying to open up. Okay. And just to give you a context, last closing slide, that most of the international platforms, including World Economic Forums, the projection says that digital solutions, integrating digital solutions with the climate technologies can help us reduce the emissions by 20%. So it's not that digital technologies themselves are capable enough to help us achieve the emissions reduction. It's more like finding a sweet spot for that. And that's what is my conclusion, that we have different pieces of jigsaw puzzle. We need to put together the pieces together to kind of solve the final climate puzzle that we are trying to solve for. Thank you. Any questions, Renz, that you would want me to address, please?
Definitely. So Ankur, let me start with thanking you for the persistence and the grit you've shown in the webinar, because I know as a speaker it's rough if things go well and you know there's an audience and you need to act in time. So thanks for that. It's much appreciated. I have lots of questions. I'm going to ask you the top 3 ones of my list of 20. So I think they're quite pressing and interesting. So the first one. How are batteries changing the climate change equation? Because of course we see a lot of electric cars and this whole transition. So what's the story there?
Okay, so I'll put it in 2 ways. I'll respond it. Sorry, whoever has asked. I'll not be able to do justice to the complete answer given the time constraint. But the overall view for that is there are 2 elements to the battery. One is the battery getting used in electric vehicle. And then second is how exactly batteries will make the renewable energy market more stable, less intermittent. Right now, the solar and wind are available only for a particular period of time, naturally. And unless and until we integrate it together with the batteries, we won't have it consistently for the 24 hours of the day. Now, there is a role for batteries there. for making the renewable energy, these intermittent sources of energy, more stable. And then the second is electric vehicles. With the demand increasing in these two segments, the demand for batteries are increasing. If I have to opine whether the batteries, how great role batteries are going to play, I think the future that we are talking about 1.5 degrees centigrade or the net zero emissions future is kind of built, is heavily based on a fact that batteries are going to play a huge role. If we do not have batteries, economical solutions for batteries, we won't be able to achieve those targets. Now, this is something that is a high level thing on the battery. I'll kind of like only just touch upon, but not get into the details. When we talk about batteries, there are a lot of supply chain issues that we need to resolve for. How do we source different elements, especially cobalt, nickel, and other minerals needed for these battery manufacturing? But then again, I'll park it for some other time for our sessions. Right now, yes, batteries are a very significant piece of the puzzle.
Okay, great answer, thanks. The second question that was quite intriguing. There's a group of students listening in from, I guess, a great college in India, but I don't know the name. And they are mentioning that they're trying to degrade HCFCs, so hydrochlorofluorocarbons. It's a greenhouse gas using some genetically engineered bacteria.
Okay.
Any thoughts on that? For me, that's completely new. But what's your? Yeah.
Okay. So I think like it's still in a very nascent stage. I'm really glad to hear that some like a group of students is working on this. Like it's something which is a very emerging market. And I think that's technology. I have been reading about this technology and having this research paper within World Bank and across. So we had this paper in the Harvard University, wherein it is used in one of the classes, that how exactly in the future, maybe 15 to 20 years from now, how exactly these kind of like the substitution technologies for HCFCs will be a significant game changer in the whole equation. I think it's a very promising thing, but it's still in a very nascent stage. A couple of things will define it if I have to give a view on that. One, that how quickly the technology mature in that particular segment. Second, how economical we are able to make it for the market to quickly adapt it. Even if not economical in its own way, whether the government incentives, whether the government policies will be able to support it or not is something that I think will be a huge game changer for this particular sector. But yes, kudos, and really, really glad to hear that a group of people, group of students are really working on this particular thing. So amazing.
Yes, same from my side. Very impressive and very necessary.
Absolutely.
Let's do one more question, and it's a question about finance and financing this whole transition. And you mentioned that hey, maybe there's 800 billion going into this on a yearly basis. But the question that I see here is, do you think that is enough?
Absolutely not. To be very honest, to start with, I'll give you the answer. We are still not even seeing the tip of the iceberg. We are still not scratching the surface. But that said, what I'll say is that even that $800 billion getting mobilized in just 5 months of this year, calendar year, is also a good start. I'll not say that it's promising to solve the challenge of climate change, but at least it showcases that the bigger incentives are getting aligned. The bigger financial institutions are really starting to take into consideration climate change as their core issues. Institutions such as World Bank, which has been living on the legacy of the development for the past 75 years, we have started taking this seriously. And there are so many other institutions that are starting to kind of like take this very seriously. Not just now, like for World Bank, we had always this aspect of integrating society together with the development challenges. But then for the private sector capital, we have seen those kind of shifts happening. We still need to reach a kind of a catalytic stage where the finances are sufficient to make the climate change a really at the core of the development thing. But we still are a little far away from that stage, to be very honest.
Great. I think, as promised, we're 10 minutes over time, and I think we spent 10 minutes troubleshooting in the beginning. So I think we've done a good job given the challenge. Ankur, thanks so much for being with us. I would love to have you again. There's already quite some questions because the topic is so interesting. And I think this feels like an introduction where on almost every slide we could go in deeper. And I think we should. So I hope we can have you again in the future to deep dive into specific elements, if that's okay.
Yes, absolutely, Renz. And pleasure having being here. It was really, I think like if we would not have that initial glitch, it would have been good to kind of walk through those digital technologies as well. But I really hope that people enjoy these texts which you send across through the mailing. Mailing.
So, I will, and I know where the button is now. So next time, if that happens, we'll be very swift with the action.
Absolutely, we learn from every experience, Renz.
Exactly. So. Thanks, everybody. And Ankur, thanks to you. And we'll be in touch very soon.
Perfect. Thank you so much, everyone.
Bye-bye.